First of all, I will thank Anthony who participated directly or indirectly to this presentation because I'm working with him for a long time, so I'm trying to extract from some of his presentation or we prepare some of the context of some common projects. So first, what is CA? So CA is a French governmental institution. In Europe, it's called RTO for Research Technological Organization. It's part of the government, so it's a governmental institution. It's about 16,000 people. We are located in France, so it's split into four directions. One which is the research dedicated on science, pure science for fundamental research. One which is for military staff, nuclear energy, and the last one, which is the most new one, which is dedicated to technology in general, called CA Tech. Location of CA Tech in France are mainly in a part called Paris-Saclay, which is close to Paris, 10 kilometers close to Paris, and to Grenoble. And this is the two main locations, and you have also subdivision in close to industry in Lille, in Nantes, in Bordeaux, Toulouse, and close to Marseille. Budget is about 4.3 billion euro. We have a lot of patents, a lot of publication, and a lot of startups created from the CA. CA is very close to industry in France, and one of the main mission of the CA is to enable transfer from research to industry in France. So my labs is called LISE, L-I-S-E, for Laboratory of Model-Driven Engineering for Embedded System. The goal of our research, the dream, is to enable correct by construction design of systems, cyber physical system, IoT system, whatever system there are. We are coming from the design of embedded system because our history is coming from the control and command of the nuclear industry. But for 10 years, almost 20 years now, we go outside this domain and try to push all this technology we did in that domain, in that area, in the other domain. So one domain where we are very active is automotive, transport and automotive more especially, but also energy system, smart grid system as well. We are about 53 persons, depending on the PhD, rigor of PhD and postdoc. It's 35 permanent people. And the research activity are, I would say, more focused on the left branch of the V cycle. So how you go from the specification to the code. And of course, we are also interested with, I would say, the right branch of the V cycle, but we try to integrate that activity into the left branch of the V cycle to enable correct microstructure, in fact. So we have activities in engineering of modeling language. We have been very involved in the standardization activity at the OMG, so OMG Object Management Group, the place where they standardize UML, XML, all that stuff. Work on formal analysis, mainly test case generation, automatic test case generation, formal verification, monitoring, model-based simulation. We are focused on safety and now on cybersecurity because we thought that there is a lot of commonality between safety and security is a high demand currently, so we also go that domain. We were working at the system level to enable exploration, architectural exploration also, and deployment and configuration and so on. And finally, we have some activity on process engineering requirement and variant dealing. We were involved in a standard called CDL, for Common Variability Language, that was mainly designed in the context of some European project. So, as you know, we have all this smart system around us now, and more we have this system. Now it's more called IoT and so on. And so there is one common point for all this system, that in fact most of their innovation is coming from their software now. So one real issue for the industry is to be able to deal with the software design, software engineering, and to make correct software. In the meantime, there is also a lot of reports saying or reporting software flow or system flow. So the focus where we are now is to enable to do better system engineering, and in that context, software engineering is a kind of system engineering. How we can improve also software engineering. So the agenda of the presentation. So I do think that I prepare too many slides. I'm sure about that. So maybe I have to skip some of them, but because you will have the presentation of time, you can look at that. And if you have any questions, do not hesitate to send an email. But the agenda is around 3 parts. So the first one will be around the concept of architecture, the what and why of MBA. You have already listened to some lectures about that. You will have my viewpoint on that. How we can enable model-driven engineering. So I will look at that at a more industry viewpoint. What are the difficulties to introduce this kind of new paradigm, even if it is not a real new paradigm, but there is some difficulty to deal with that. And I will have a focus on this kind of system called mission critical real-time embedded software engineering. So let's go for the first part. So why it's very important to be architecture-centric, I would say. It is because of one of the main principles, which is separation of concern, which is a very important principle to be able to deal with complexity. So the separation of concern principle can take several aspects or several forms. We can call it design pattern, aspect-oriented, service-oriented. All these keywords or all these disciplines are in fact related to the purpose to provide features to deal with separation of concern. All this way to develop relying on concern are also sharing the same thing that all the concerns, what they are called design pattern, aspect-oriented or service-oriented, are not independent together. So in fact, the complexity is coming from the dependency between the concerns. If each concern was independent, there won't be any complexity. I don't know if you know, complexity is not the number of things, but the number of relationships between the things. If the people were not connected, there won't be any complexity. As for example, you have the performance versus safety, cost versus security. And in fact, it's performance versus safety versus cost versus security. And this is the problem. In fact, the problem is coming from this dependency and relationship. So what is required is to have a big picture approach, or a so-called holistic approach, sometimes in the papers. That is the ability to deal with the relationship between the things together. In our context, we are using this standard as a key reference for the vocabulary, which is 42.10 standard, which defines this concept of architecture description, viewpoint, view, and so on. Even if we can discuss and improve the content, so it's a basic set of definitions for us. So one thing also which is related to architecture description language is that this kind of form of design, of development of system is not very useful to be about architecture. And there is something which is clear, even if you can discuss about the added value of the graphical language, is that graphical language are better suited for dealing with architecture concern. It's much more easier and faster to look at that and to say, okay, this is the components or whatever you call it, module or subcomponent system and so on, which participate in the system. They are connected there, and here is an example of interconnection. And if you look at that, it's a bit more difficult to spot on that. Okay? So we can discuss text, and I will come back later on that text versus graphic and so on. I do think that this is for anything which is related to architecture, graphical language. architecture are very important also for requirement engineering. And requirement engineering is one of the key issues when you deal with system engineering in general. If you have bad requirement, you will have a bad system, or at least you will have a cost which is very high for designing the system. And so the architecture description is very useful to deal with this required iteration, where the system architect will have to study, analyze different possibilities, and in order to say, okay, this is the best one that satisfies everyone. Of course, no one will be fully satisfied. They will have to make a compromise. And this is really the purpose of what we call architectural exploration, to deal with that and to provide the better architecture or the less worse architecture. The next point about the third things with regard to architectural exploration and architectural description is that it's also a means to reduce the risk. So if you look at this graph, this curve, so in blue you have the curve that explain that the more we go and when we deal with some system design, you increase your understanding or confidence level with regard to the understanding of the problem with the time. So the more you study or the more you know the problem, the more you can have confidence that you know it. Okay? And so in parallel, you reduce the risk of the design. And so one of the problem of the industry is to look at that point where you have this level of confidence and this level of risk. And of course, you know that as soon as you can know the problem and reduce the risk, as less the cost will be to deal with some issues. So the real intent using model, for example, being able to do exploration, architectural exploration, is to reduce that time, in fact, to be able to deal with the issue as soon as possible. And it's for that problem, if you look at agile method, for example, whatever it means or whatever the buzz is behind agile method, one thing we can say for agile is that agile is a means to reduce the risk, because when you do that, you can spot or you can focus on a part of the system where you think the risks are. So the architect or the system architect may know the part of the system design where there may be some difficulty, so he will focus on that part and make some deep, I would say, design or so on, only on this part to reduce the risk or to master the risk as well. Okay? So summary on what are the benefits to the architecture centric is that it improves stakeholder communication. So by doing that, we deal with complexity. We provide tools to deal with complexity because we foster communication between the people working in the system. So in the meantime, it enables the people to work together because they share some concrete description of the system and a common description of the system. And then, because what I just said, using that, we can make exploration, we can reduce the risk by providing some facility like a model simulation or formal analysis. You can perform model checking, as for example, on the system description. So the complexity, we were talking about the complexity. It's interesting to notice that we can have two kinds of complexity. The complexity of the system to design. So as you know, people want more function, more concern, and of course more interaction. Well, this IoT, for example, one of the features of the IoT is that these systems are interacting a lot. So this is the complexity. But also the constraints against the design are also increasing. Of course, you have to work quicker. If you look at the automotive industry, for example, so maybe 20 years ago, they produced a new car in 5 or 6 years. Now it's less than 2 years. So they would like to be able to provide in the future a new feature based on software. Every month, you could download new feature in your car very quickly. You have constraints coming from standard. So a lot of standards, safety standards, security standards, and so on, local regulation law. So you have to satisfy. So it makes the things more harder to do that. Of course, quality has to be better if you want to be the champion of the market and cheaper. So the complexity is coming from all these two kind of complexity, and doing some failure. So, what is the to deal with complexity? What is the most ancestral principle we apply as human? It's in that abstraction. So, it's a mean to deal with complexity is to look at the system as a simpler system, the less complex system. And if you look at modeling, modeling is indeed a mean to make concrete abstraction, okay? Not abstraction in your head, but you can put it on the paper, on the computer, and so on. So you can share, you can work on it, you can think about it. So if you look at the traditional design approach, in fact, you have stakeholders, people, and these people exchange information. The exchange of information can take several forms. It can be code, it can be papers, just ID as a coffee break, email, models, and so on. And you have a dependency between all this information. Usually I put dot line because this dependency are almost completely informal. And so the difficulty with this kind of design approach, and this kind of design approach is very, if you look at current practice as system engineering, they are working with that. Because the tools they are using is mainly the Microsoft tool suite. So it's Microsoft Word, PowerPoint, and so on. So when you create the information with this kind of tool, there is no relationship between the information that are...
They talk to us.
Exactly, at least they should. So they need also to model. So first, this kind of process is unreliable. It's very error-prone as well, because one of the main errors we can look from system engineering like that is that copy-paste error, in fact. When you create a new document using another source document, a design document using a specification document, so you will reuse for sure because you have to go fast. So you will make copy-paste, and as soon as the first document is updated, the second one will never be updated. And you can have very big flow in the system document just because of cut and paste error. It's inefficient for the same reason. If you want to deal with co-evolution or evolution of system, it will require a lot of handmade work to make consistent every document. And it doesn't scale because, in fact, as we said, the systems are more and more complex. So the stakeholders involved in the process there are more and more people involved in the process. So more and more information exchange. So more and more possibility to have error. So what is the promise of model-based engineering? What is the main things between model-based engineering? And for that reason, you can see it's not very new. It's not a new paradigm. Moreover, for people working in computer science or software engineering. The idea is to put the information in database, whatever it is. So just to have the information in a form that the computer can use it in order to help or to make automatically some work. And you need, because we cannot save everything in one format, in one place, and so on, you will have several databases of the information. You have to connect or link the information together explicitly, either by having relationship between the information, we also mainly call that trace relationship, because thanks to model transformation, it's a way to explain it's a kind of imperative manner to express a relationship between two kinds of information. Model synchronization, it's a bijective model transformation, to make simple. Or this kind of code generation or documentation generation, which is also called M2T transformation. This one going from model to model. We will have still this kind of informal exchange, but you already have everything. And so what is expected is that to have a more reliable process by having automatic transformation or automatic connection between the information. It's promised to be more efficient. For example, synchronization between two data will enable to have real synchronization. For example, I will come back on that later, but an example is I have an architecture description and I have an implementation between C++ or Java. So thanks to synchronization facility, you may be able to synchronize the three points of the system. And more scalable because of the fact that computer can take the stakeholder involved in the process. You can deal with more information at the same time. So the three purposes of the engineering model are first to facilitate communication between the stakeholders, then to provide a concrete support to work on the design, and then another possibility for the usage of the model is that the model will be able to be used as blueprint of the system, formal blueprint of the system. So there is indeed a direct path between the need and the need to be architecture-centric, and the fact that the design will be model-based or is model-based now. So this need to express the concept of the architecture description, mainly decomposition, abstraction, and view. So these three concepts, decomposition, abstraction, and view, are concepts that are supported by model-based engineering, and the ability to denote all the relationship between model elements in the world at a different abstraction level and in the different views we can provide. So we can see that could be a definition or a definition of the paradigm for model-based engineering. Model-based engineering is that model-based engineering fosters computer-aided development, including stage like specification and design. So I make a distinction between specification and design mainly as a specification is the time when you define what is the what of the system, what is expected the system to do, what are the requirements of the system. And the design is the time where you define how the system is going to implement the specification. And to enable correct byte construction, just using the computer in the middle of this kind of complex system. We can say that MBA, model-based engineering, is relying on two main pillars, abstraction and automation. Abstraction is mainly what we call, for research, it's mainly the area of modeling language engineering. What are the good concepts, what are the good abstraction, what are the connection or refinement relationship between the abstraction. And automation is the domain of the tools that exploit the model. So here you define how you formalize the information, and here you define how we can exploit this information. Why it is so important to have this automation is that mainly to enable to, so we have this, in computer science, we have this domain called, in France we call it formal analysis, that means mathematical analysis, that also means for industry very difficult to understand. Okay? And in France, but in the world, we are working on this kind of technology at the research level for 20 or more years than that. But in the industry level, there is few people who are using this kind of result. There is a mega octet of research paper on that subject, and not so many people using it at the industry level. And one of the expectations of model-based engineering is to, we say, to hide this kind of technology, but at least to make this kind of technology accessible or usable by these engineers. Because we won't be able to to do the work in one model and one stage. So we need to abstract, but to have the system done, we need to refine this abstraction until you have the system ready to be used or ready to be sold. We have this ability to, we have this need to get to another refinement-based process. And so this kind of tool will improve the robustness of this kind of process just by avoiding to base the refinement of the cut and paste features. More efficient because there is tools that can verify, track, and propagate the change. It's called co-engineering or co-evolution. And we can also provide facility to enable the documentation generation or code generation. And finally, we can have some ability to have this process enactment feature, that is the ability to monitor, drive, or synchronize the process itself that is defined to develop the system. So, I do think model-based engineering is already available in engineering for a long time, but one of the main added value of this current work is to be able to go from this way, where the model are said to be contemplative. So the human has the model, so it's already good because they can put the model on the table and they can discuss and so on. There are some difficulty behind that because it depends on the size of the model, but it's, even for a human having this clear or explicit description, it can become difficult to have the view of that model. So we need to help the human to understand the model by putting some assistant in the middle. Okay. So this is clearly the goal and the challenge behind model-based engineering. The second challenge is to put these smart things in the middle to help the user to better understand and to better understand the problem that is abstract into the model. One of these kind of tools is simply, as for example, simulation. But even simulation is a problem, in fact, because today, currently, the simulation facility that are provided in the tool are more for marketing purpose than engineering purpose. I mean, using simulation facility, you can make you can improve the understanding of a model, but there is so many assumptions, I would say, behind the simulation model that you are not very sure about what you see.
You cannot reason this.
You can only help the human to reason, but the
first step, but you cannot reason.
Yeah, exactly. And one also with the current facility, with simulation facilities, you can also drive the people in the wrong way. Because of the assumption, for simulation there are assumptions. Maybe the user don't know the assumption, and so he will conclude something from the simulation that is wrong because it doesn't understand the assumption behind the simulation. So the simulation facility may be a risk also for people now. Okay, so there is a real challenge here, in fact, for providing the good tool for the people to understand and to understand easily the model. So 4 key benefits behind MBA. Working with higher level of abstraction, that means closer to the problem domain. Automatically traceable links between related model elements, so very important for complexity management. The third key benefit is to have real representation of so this stakeholder-oriented representation are usually called views of the complex system, and ability to automate some engineering tasks. And so if you look at these 3 key benefits, in fact, each of them will contribute to, directly or indirectly, to the quality, productivity, and complexity management exposure. So now I will have some slides for each of the key benefits maybe it's not exhaustive, but you can discuss later if you want this thing. But I look at these key benefit features under these three aspects and try to list for each of them the real impact. So for quality impact, being able to work with higher levels of abstraction, sorry, will foster creation of a simpler, better, and structured design of your system. In terms of productivity impact, what is expected is that it will reduce the cognitive load on developers. Because you will, by providing these tools, you will reduce that effort. You can say you will reduce the cognitive load on the developer, or you will also, you can see that on the opposite, that you will enable people with less experience to work on the tool. But for industry, it's maybe also very interesting because of the difficulty to get the right person for the system development. You will simplify the communication between stakeholders because they need more. The problem is abstract, so it's evident. You will simplify the post-release maintenance due to the fact that you have better documentation of the system. And in terms of complexity management, you will reduce the need to perform domain to technology transformation. And you hide, which is one of the expectations of abstraction, you hide implementation or technological details. For the second key benefit, automatically addressable needs between related models. The quality impact, for the quality impact, so you make easier detection of complex system coupling because we see the connection, where are the connection, and we can see some scenario or main scenario of the system behavior. So it's a mean also to simplify the assessment of requirement coverage because you can trace what is implemented. So it's simple, but it's very useful for industry. And you can also detect what are the design parts which are useless, in fact, or not used by the system. And you can also eliminate duplication of information into your system. So you make better system like that. In terms of productivity, you make easier the detection, so quicker the detection of design issue, or still coming from the fact that maybe you forget that some parts were connected. You can have it's very common issue in software design. Simpler post-release maintenance and minimize and eliminate information duplication again. And you also will enable fast and reliable support for finding couplings. So you will provide facility to improve or to make easier complexity management. The third one, for the quality impact, so you will enable more accurate capture of both requirement and design intent, which is very important for having a good quality of system. For the productivity, we will foster faster and more reliable decision making because the fact that you improve the communication between the stakeholders and you simplify post-release maintenance also, which is has an impact on the productivity. And finally, you will reduce complexity because also again you write implementation detail. And the last one, ability to automate engineering tasks, has an impact on the quality by reducing. You can also guess eliminating errors caused by this cut and paste error we were talking about. Sorry, I lost my pointer. Increase the chance to have good decision, in fact, by providing this tool in the middle. Reduce the design risk. Productivity, accelerate execution of key stage in the design process, because you will automate all the basic stage, in fact, that you you have in your process. Early detection of flow, increased confidence of the design team, because they will be, so it's, if you come back to the curve I saw you between the risk, to be able to deal with the risk earlier in the design. And finally, you will automate the ability to deal with complex analysis, because in fact you will, thanks to model-based engineering and this ability to encapsulate this formal analysis, you will make the ability to use this formal analysis, which was not the case until now. If you take an example as, for example, a real-time system, one of the things you need to validate is the deadline, if the system meets the deadline. Okay, so there is a big, again, there is a lot of paper, research paper on what we call schedulability analysis. It's a lot of different schema. We are working on that for more than 20 or 30 years ago. One of the basic results that was provided by Stankovic, I guess, several times ago, called Rate Monotonic Analysis. There is a great book on that, very old book. People are not applying, or almost not applying this kind of result because of the mathematical form of the result, in fact. So even this kind of basic mathematics is not used because it looks like mathematics. Okay, so engineers don't use it. And so there is now some real, there is some tool providing, if I have some time, but maybe in the afternoon I can show you demonstration. We can provide an easy access to this mathematics to the engineer just by encapsulating them into a modeling tool or this kind of.
Actually, what we prefer is that this is the most critical obstacle.
Yeah.
For adoption of model-based engineering, model-based engineering, it's called the performant. Make it easy for engineers or scientists or analysts from different domains to use this tool.
Yeah.
Investigate the way we have it right now is too complex to be learned so practical.
The user experience. But okay, we will discuss that later because in the context of Papyrus, you discuss a lot this user experience thing. People asking us to reduce that or reduce and reduce and reduce. So sometimes I told you maybe you should increase the level of competency of the engineer. So maybe I don't say that like that, but there is also an issue with regard to education.
Sure.
So there is a balance between reducing the level of the user experience and to have better user experience, and a balance to also educate the usage of the tool, the technology, and so on. So summary, model-based engineering, MBE. I use the term MBE, or sometimes people are using model-driven engineering, model-based system engineering, model-based software engineering, model-based system software engineering.
I just use model-based engineering.
So it's like,
I just use model-based system engineering. I'll explain why.
Exactly.
Model-driven, however, it's also
a model-driven architecture.
No, the reason I use system engineering because system actually means integration.
Yeah.
So everything you're talking about is there because you're going to integrate.
Okay.
So therefore it's model-based system engineering. The rest of the stuff I don't accept. So that's right.
Okay,
That's
so
me.
you can put a list.
That's me.
For me, it's everybody.
Okay.
Okay. So it's a paradigm, in fact, for designing an implementing system. Okay, so it's just based on this mainly two things: abstraction and automation, computer automation. That's all. It's not graphical, it's not text, it's not UML, it's not XML, it's not whatever you want, it's only that. Okay, and after that, it's a means to do that, but MBA is that. Because usually people say, okay, MBA, yes, it's XML, it's bad things, or it's UML, so it's bad things. No, it doesn't matter. It's text or it's graphic, it doesn't matter. This is not the question, not at all. Okay, MBA doesn't mean graphic or diagram. Something completely different. MBA means that abstraction, computer automation, or computer assistance. And the key benefits, the expected key benefits are increased productivity, product quality, and ability to deal with complexity. Maybe the last one is maybe one of the first. In fact, I would say the main key potential is to increase the capability to deal with increasing complexity by having at least the same quality, even better, I say not reducing the quality and being able to do it more quickly, even if that at that time they're always not possible. So you have to stop to try to go faster. So MBA, it's not a new thing, okay? And in fact, it's already applied for a long time. And there are a lot of reports, and a lot of reports that provide good sign, even if people can discuss again, definition and so on. But there are several systematic studies that I list this Q1, which is one. So ONG, I think it was 2009, make a request for information, verify, to know what was the usage of CSML and what was the current usage of CSML in the industry. So it was very interesting. It was a big survey. It was 22 questions and 39 usage questions, so language question and usage question. There was almost 128 industry who was responding to that, coming from 16 countries, so it's quite representative, and coming from 45 different industries. Okay, 61% of system engineering, 17 software engineering, and 22 other managerial executive and so on. So it's a very interesting report, even if it's 7 years old, but it's interesting. There was also this report done by research people, so mainly John Richardson and John Whittle. I guess it's the most completed empirical study, and that's very interesting also. You can look at the report. And there are indeed several other reports that you can look at. One which is older from Motorola, 2013. So we can see that it's not so new, recent, but it provides good things and bad things also, but good things about the MBA.
But none of these reports talks about design space exploration.
Not really, they mention.
Not really, not nothing. I mean, they just talk about it, but none of them gives any idea about how we use modern languages and couple them to design space exploration. None of them.
Yeah, but design space exploration is not provided by tools that are used by industry.
Fine, but we have tools.
Yeah,
there are tools
in the research, again, in the research I can list you a lot of people making design exploration.
To me, that's one major recap that we cannot succeed in transferring industry coupling of design space exploration tools to modern tools.
It's a general issue, in fact. We lost a lot of transfer opportunity between the research domain and the industry domain. Exactly. So, I don't know until what time I have.
You have time.
Okay.
You have at least 10 more minutes.
So this is a summary of the impact study. This impact study, in fact, also reveals that MBA improved productivity and product quality. It was claimed by the industry itself. Okay, so it's already there. It improved communication between stakeholders, so it's also improved ability to deal with complexity. They claim that it's improved maintainability, which is a very important point. Maybe we do not consider this point at a sufficient level in the research part. We are more focused on the design time of the system than the maintenance time of the system. So for industry, it's very important. And faster introduction of new development stuff. So it's one real question for the people is the ability to have the good team for developing system. So based on these two. So this impact study was based on these two kinds of reports. And then what is very important to see also within this report is that it can be a success only if the introduction of model-based engineering is done carefully and not too fast. This is one of the main issues. On my side, I'm meeting a lot of people who ask me for results for 6 months. And so I think they are dreaming. Okay, they won't be able to have a revolution in 6 months. So this is a big issue also to be able to say, okay, it will take, there is a report on that or something. Let's say it's a 7 years long process, or you can say 7, 6 or 5. NASA, for example, took 7 years to introduce model-based engineering in the process. It was very good. It was done very scientific manner, I would say, very concise manner. And you cannot expect results if you want to do it too fast, in fact. You will go to the wall, I would say. So how to enable model-driven engineering? As I said, it has to be very clearly and very carefully done in a systematic manner. And so the main impediments are not technical indeed. There is some impediment, as we said. You need more useful user to provide a more better user interface. You have to encapsulate this new technology very smoothly and so on. But the main hurdles are coming from, in fact, social issues, introducing new things into a company, asking the people to change how they work, how they think, and so on. This is the main problem. So this part of the study, I did it with Bran, and it was very interesting because you try also to list all the issues related to this introduction. In fact, you can copy that for anything else than model-based engineering. Okay, it's a problem of change management. It's a generic issue of change management, whatever.
Can apply MBE to the MBE application itself.
Yeah, sure. So this is a list. In my presentation, I have also some refinement of the list. I will skip that due to the time that you have the information. So, as a summary, so as I said already, it's not a 6-month project. It's something that takes time. I can say we are working. At the end of my presentation, I put an example with an industry called Plastic Omnium Energy. It's an industry working in the automotive industry. We started working with them 4 years ago, and we only have the first result now, introducing model-based engineering. But it is because it is done in that process carefully. We deal with some parts of the problem. How to describe my architecture, how to introduce a connection between the test team and the architecture team, how to introduce, how to deal with the link between the safety engineering and the system engineering, and so on. We did it in an agile manner, I would say. We have this success now, and we can continue because we can see, okay, we have some good results. We have a return of investment. But it took some time. Okay, and one thing very important also when you introduce model-based engineering or whatever you think is that you have to set up, and for PhD students is the same by the way, you have to set up a kind of validation framework. So how you are going to assess your result and measure your result, to measure your progress in fact, but also to, if you miss something, because sometimes you can have failure in your design, you can say, okay, no, it's not so good. What can we do to improve that? And for being able to do that, except doing something like that, feeling that it's good or not good, that we do a lot for in general, having this kind of formal framework is a means to drive your work and to convince the others that you did good things. So it's very important in that case. Because as I said previously, the main impediments are not technical, but there are some technical issues, of course, also. But these technical issues are not insurmountable, in fact. We can deal with that. If you work on them, it's okay. We know there are solutions. This is the difference between the social issue. The technical issue, we know that in some times we will have a solution for dealing with them. Okay? So for the tooling aspect, the usual suspect is scalability. Scalability is it's an endless question. We will always have bigger model or bigger system to develop. So I say in French, we say travail décisif. So it's an internal. There is no end to that a priori, not at the size of my life. Adaptability, the mean to adapt to a tool to be adaptable to a user. For example, if you have an expert, the tool should be designed for the expert. If you have a novice, the tool should be designed for the novice. You have someone in the middle, left hand, right hand, big, small, and so on. The tool should adapt. In other case, it will not respond 100% to the need. Of course, interoperability, because as I said also in one of my previous slides, there are a lot of stakeholders with a lot of formalism or specific formalism. And so they need to work together, so the information need to exchange, so the tool need to be interoperable together. So we see a lot of people on that. The cost of license and training, of course. And finally, the most important is usability, also called user experience. You can see a lot of paper on that if you want. A tendency in the context of the MBA tooling is this tendency to go from what you call vendor-driven strategy to user-driven strategy. Currently, if you buy a tool, you only buy the tool with the features that are defined by the tool provider itself. And if you want to have your own tool, you have either to pay for the design of a specific tool, it costs a lot. We did that in the 70s or 80s, but it was a catastrophe, I think, for the industry. Or you use tools that are available for everyone, so they are generic tools. And when you buy this tool, you may have possibility to adapt or not, but usually you don't make it because it's cost a lot. And you have this also vendor locking fear, and it's very interesting to look what happened currently in the model-based area, because we see more and more companies, tool providers that develop the domain, because the return of investment is not as they are expecting. They are expecting, for example, IBM is expecting more than 10% of return of investment, and in that domain it's not so big in fact, because also companies want to reduce their spend in the license cost, so they buy one for 10 engineers. In 80s they were buying 10 licenses for 1 engineer, so they are not making enough money, so they are starting to push out this kind of market from their portfolio. So there is a great increasing interest and investment in open source. It seems to be an alternative to that situation. On our case, you are working a lot with Ericsson, for example.
Yes.
We really did that step. But some companies also like Airbus or like SAB are also making that. And more companies are looking at that as a solution.
The Ericsson is going fully open source.
Yes. So, what are the main expectations? Also, because with open source, you can expect to have the core technology inside your tool. It is one expectation. We can discuss that offline if you want, but it's some issue. Technology should be also, in that case, in line with industrial needs, because if the industrial are part of the process to define or to implement the technology, a priori it should be closer to their need. If you look at that, for example, for Ericsson, so Ericsson was using massively IBM tool for modeling, and even if they were giving a lot of money to IBM, the ratio behind their request for enhancement and the new feature in the tool was 20% of their requests for enhancement was implemented, only 20%. Even if Ericsson was a quite big client for IBM, you could say, okay, it's a big client, so IBM will implement. Indeed, even if it is a big client, with regard to the amount of clients, it's not so big. So they cannot, I don't know if they cannot or they don't, but they did not answer in a satisfying manner to Ericsson. And due to the pressure to do better tools, to work faster, and so on, they wanted to inverse this ratio and having at least 80% of their requests for enhancement satisfied. And to meet that goal, that objective, they only see open source as a solution. And the ability also by open source to be able to make share funding, in fact, for their future. Standard is also very important because open source and standard for model-based engineering is also a good thing, because if a company like Ericsson don't use standard, where they will find anybody to share with them the cost, in fact. If they do only specific things, no company will be ready to use their specificity. So they need to have a strategy based on standard if they want to enable cost sharing, in fact. It's very important for that purpose, but also for some other features, but standard will improve and increase the technological use. For example, for UML, it was the case. If you look back in that time, when UML is born, at that time, object-oriented paradigm was trying to emerge. And there was so many propositions that it was very difficult for a company to make a choice at that time. Because there were so many companies providing solutions, and usually small companies, so there was risk to adopt a solution provided by a company. And as for example, in Europe, Airbus, maybe you remember, but Airbus was adopting an object-oriented method called OOD, hierarchical object-oriented description. And there was a small company, so it was nice conceptually and so on, so they adopted for that purpose. And there was a small company providing a tool, selling a tool called Stud. The problem is that after investing some millions of euros in education and in tooling and so on, the company was closed, in fact, because Airbus was maybe the only client of the company. So there was no market for the company to define the tool. And so Airbus was it was very difficult to Airbus to deal with that situation. They have to find someone to maintain the tool, so they have to pay a lot of money in another company to adopt the tool. And even in that case, it may not be possible due to IP issue. Because the IP is a part of the company, so if the company is not bought by another one, the IP is lost. You are very stuck by that. So UML was a mean and the standardization of this language, whatever we can say about it. It was really a good thing for that purpose. So the problem, so it's not my slide, it's a slide from Ericsson. So the problem is not UML itself, but the tool that provides support for UML. And it is clear that also on my side, I met a lot of industry people that say, no, UML is not good, but in fact they are saying that because of their experience with the UML tool. And in fact, if you know UML, if you know the tool, you can say, no, it's not due to the UML itself, it's only due to the tool that doesn't implement the complete UML. So you should be able to do that in UML, but with some limitation of the tool, you cannot do that. So it gives me the ability to introduce a tool called Papyrus. So the tool we are developing in the team, I will explain that it's not really in the team. It's bigger than my team that are participating to that tool. So it's an Eclipse project. Eclipse is an open source foundation that provides a lot of tools for free and in open source model. The license is EPL for Eclipse platform, Eclipse public license, sorry. The website of the tool is there. And Papyrus is a project that delivers a UML tool, UML and a CSML tool, but it's dedicated to experienced users. And really when I say that, I say we have not introduced in the basic version of Papyrus any methodology called help. So if you know well UML, it's a good tool, you can use it. If you don't know UML, you have to stop and learn UML first. Okay? The basic version, the open source version, is an implementation of the language. That's all. UML and CSML. And we also provide, in addition to this implementation of UML and CSML, we provide some facility called the Papyrus for Toolsmiths that provide you the ability to define specific version of the tool, simpler version, I will show you an example, or version where you introduce some methodological assistance. So Papyrus, one important point for open source, the open source is the community itself. So Papyrus, it's a set of companies that are involved inside the tool. So you have several big companies, small companies, academic.
But you don't have the association?
Not really, yeah, because the system is more today one.
Yeah, but the association, I mean, I'm the main problem is they have great tools, but they have not succeeded in integrating their tools with current state-of-the-art model-based system engineering.
Yeah, but also the problem of the system is like MathWorks, it's companies that want to do everything on their own without any connection with the other. So maybe it will change in the future because it's not realistic or industry don't want that anymore.
Okay, you're right. I mean, I've been saying this for years. IBM gave up on that system. Siemens is going that way, but the source system still.
Yeah. ANSYS is going this way, and Siemens is still going this way because they are buying, in fact, a lot of companies.
There is some progress there.
Okay, so good. But Dassault system is still working on that kind of paradigm. And we are working, we have contact with Dassault Aviation, by the way.
Okay.
For example, because Dassault system does not provide any solution for software engineering. So for software engineering, we have some contact with Dassault Aviation, for example. So for the moment, Dassault Aviation is not far, but you can see ANSYS. Because if you, maybe I don't know this, that ANSYS has bought some years ago a French company called Stereo Technology, which provides a tool called Scale System for design of mission critical system based on some concept of synchronous language. I don't know if you know that, but it's code generation and so on. And so they have a tool called Scale System for system engineering, and Scale System is based on Papyrus. It's Papyrus. So, and this is part of that. So some of the company I was listing in my previous slide has decided 2 years ago, but it's official from the beginning of this year, to structure their effort and their need into an industrial consortium called Papyrus Industrial Consortium, which is part of the Eclipse working group called Polaris.
Is the Papyrus consortium open to international users?
Yes.
Okay.
The big company are European one, but they are quite international. Papyrus is an international one. Okay. Saab and Airbus. And if you look at the participant member people, you have some Belgium, you have some here. This is French. This is Swedish, and this is a standardization organization.
Right.
And you have a Canadian company, US Canadian company, German company, French institution. And for the university, the list here is more European, but it's open to any kind of people. So really, in fact, it's a native working group. So by that, it's an international consortium. So Papyrus is also people, and it's a lot of people now involved in Papyrus. And one these people are people who are directly involved. I don't list the people we don't know first, and I don't list the people who are making external contribution. It's mainly people who are Eclipse committers, officially. And it's people, so it's people coming from CA. I am the project leader of the project, but it's also people coming from academic sides. Maguette Elassar, for example, is working at GPL. It's the next IBM guy working in GMS tooling. There is people working in French SME, but also individuals. It's the next IBM also working in Canada. The Ixos is an SME in Canada. As I said, Eclipse Source is a German SME. STRL Technology and CIS. So there is a diversity of the people contributing into Papyrus.
So STRL is connected to this?
Yeah.
I see.
In fact, you have the CA, we have a contract with STRL to do open source activities. And
Is STRL open?
Sorry, no.
STRL is not open?
No, STRL is not open. The scale system tool is based on Papyrus. It's an integration of Papyrus in the
What about Signal?
in fact, no, STRL is no more using Signal. In fact, they are using now LISE the
LISE, right.
Yes, it's LISE based, in fact.
Because I heard of the list here.
Yeah, I see on the program. But in fact, some time ago, STRL jumped from Signal to LISE. Yeah. It was also, it's interesting because it was due to industrial issue at that time. Because Airbus was using LISE, and again, the company behind LISE was killed. And they need to find someone to deal with the maintenance of the tool, and they have a contract with STRL Technologies. At that time, STRL was working on a language called STRL, which was close to Signal. And at that time, they decided to jump to another technology, LISE, which is another synchronous language in France. But they jumped from Signal STRL to LISE. I will skip the demo. I can show it.
So the UML you have now is the latest version, the correct
UML 2.5.
With the correct state charts and everything, and the semantic model, because there was a lot of problem with having a correct semantic model for UML for years.
Yes.
And various companies had products that they were not correct.
Papyrus itself provides it's a modular, so it's syntactic.
Okay.
Not semantics. It's semantics because inside Papyrus there is no by default execution engine. So we as a CA provide an addition to Papyrus. It's part of the open source project which provides execution. And the execution we are providing is based on the work we do at the ONG called PSSM for precise semantic of state machine. So I have some slides on that later. I can compare that. So it's part of the generic initiative.
But the question I have is, if I use your UML and all the tools you give me, can I actually do automatic code generation and it will be correct in various languages? Can I do that?
It depends on what you mean by correct.
So I mean, if I take your model and I'm strictly talking software now, I use it to generate a Java code or C++ code, and when I put it on the computer or something, I will run into no problems.
I think you have all the means to work on that direction now, but there is nothing today already packed for that, already packaged for that. No, because in fact, at the standardization level, there is no standard specifying the template for generating C++ or generating Java. Currently, there is no standard for that. So here, it's an interesting question. So at the UNJ, there is this work on formalizing UML that starts, it's another year, 8 years ago, I did not remember, by having this FUML standard, foundational UML. Foundational UML is a subset of UML. It's focus and...
You have that? Well, the reason I'm asking you for that is usually in discussions with industry, when we come to this point, the trade-off between the difficulties you described and why they should adopt this is exactly that now they can actually, if you can give them automatic code generation that works correctly, That saves the time and effort and errors, and they like that. So that's an important thing to offer.
It's part of what is done in that context. In fact. Here you can see the roadmap for execution, or formal execution of the object. So they start by the UML 2.5 version. That was the first attempt to improve the semantic description of UML.
Yes, yes.
It was clearly a good work, but it was still an informal work, I would say. Okay? And second, they were working on this Hive specification. So it was textual things, but again, it was not a formal definition of UML, but it was part of the roadmap to have this Java description, FUML. And then you have this more formal semantics of UML definition. So you have FUML, foundational UML. Inside foundational UML, you have some kernel called basic UML, and this basic UML has been defined using PSL, procedure specification language, defined by the list, that provide a clear.
But all this done is finished now, right?
Yes, this one is finishing, and they are just the map.
So in the tool set you provide from your project,
We provide
are all these supported?
we provide an implementation of the FUML for the execution engine, in fact. And then there are two other additions of two new standards. So this one is the PSCS, or precise semantic of composite structure, so the component part. And this, I will come back later. And the last one, which is, so next week there is an OMG meeting, and they should vote the 1.0 version of PSSL, which is precise semantic of state machine.
Okay.
And then FUML, it's part of class diagram, activity diagram. It's a subset of activity diagram. And we have this textual counterpart of activity.
Because you will hear in the discussion we will have here is that we have a program, which is a Master of Systems Engineering, and one of the things we run into is the difficulty of teaching this stuff. So, to teaching this material and at the same time teaching concepts to students that are at the master's level. And to overcome the difficulty, we have to create actually sometimes our own interfaces, where you can go from text or conceptual things to correctly, syntactically and semantically UML models. And then actually, this is a big problem. And it is at the heart, in my opinion, of making these tools usable and interesting.
So the issue with the semantic.
And then we'll talk about the problems system, which are even bigger, but otherwise, in other words, what I was told by many people in the industry is that, John, you cannot expect us to have people on any desk that they have 5 PhDs. This is not going to happen. So unless these tools become usable and hide the difficulty to the average engineer, I don't think the future is very bright. That's
it's interesting discussion.
That's what I'm hearing, right?
It's an interesting discussion.
Yes.
Maybe you know MATLAB simulating and so on.
Yes.
Is it easy to? Is it very easy to use MATLAB simulating? No, not at all. MATLAB, yes, you know MATLAB simulating and so on. It's a tool it's a very complex.
But I can make it very easy by using exactly what you said.
Yes,
make it almost graphical. I can say black boxes, black boxes, black boxes. I have a library, connect them. The library tells me if I connect them the wrong way, and the engineer can go and see, okay, the simulation is done, I'm done.
Yeah, but the question of accessibility is it's very difficult to deal with that.
Yeah, but I mean, he's the director of our system engineering program, and that's the thing we are running into. I mean,
it depends on the people who are working with. For example,
he says, but you have to. Okay.
I think you have to. But for simulating, for example, the people who were using simulating was control engineer.
Yes.
And they were educated using this kind of tool. For system engineering,
educated is a big word, but anyway.
Yeah, but they have some concrete experience with the tool and so on. So they were a bit aware of the tool before going to the industry. Of this kind of tool. For system engineers, the tool they know is Microsoft PowerPoint and Visio in the best case. Okay?
That's
so
not,
when I discuss
Sebastien, that's not a tool. Okay? That's not the tool. It's a way to.
I know that, but this is their tool. When I met people from industry as a system
he tells me, John, you will meet one more time. He tells me, I don't want to point at him. He tells me that several people from industry, when we talk about trade-off analysis, they don't want to go beyond, Visio or Excel.
MATLAB and Excel are the two things most people end up using.
So, I mean, he's talking about perceptual problems. we have a big perception, a cultural problem. Right? We need to move from that to where we want to go. So, and you know, we're trying, but anyway, I mean, I don't want to take more of your time.
No, but I will, in fact, I will, I think, go to the final performances. So, this is how it's constructed at UMJ. So you have FUML, and against FUML, they build the extension with the rest of the UML part. So they have done that, and the next one should be for interaction, sequence diagram. And we have something for profiling, which is
profiling is very important.
Exactly, because it's part of the DSL.
Yes.
So so we have done a paper at the Models Conference on that. So this is profiling and interaction, which are the two on the list. But due to the effort, I think we start by interaction and then profiling. And it's, for example, the last things I will show you, which is a demonstration of one of the extension of Papyrus for execution.
Okay.
So here you have this ability to describe structure and activity,
Yes.
and then you can connect an execution engine. So you can make a choice here of the execution engine you are choosing, and then you can execute. So in the site, in the tool, you have this execution facility that will provide you the ability to have simulation. And what is interesting here, and what is new, in fact, here, is that I can send you a document that specifies the semantics of the language. If you use Simulink, there is no document specifying the semantics of the simulation. And moreover, when you generate the code, the semantic of the code, the execution of the code, is different from the semantic of the code.
Yeah, because they had this problem, right, in MATLAB, which we knew for years, that if you change the graphics, and then the program changes. I mean, and they finally fixed this after 3 years, right? But anyway.
So here you have this ability to animate related to the simulation.
All right.
And what is important is what you said, it is formally defined. And one important thing into the new specification, which I think it's also an answer to your question, is that part of the specification is a tool, it's a test suite that can be used to assess the correctness of an implementation with regard to the specification. It's the first time at the UMJ for a long time that the specification is also providing the assessment test to validate that the implementation is conform to the specification. At the UMJ, they were doing that with Corba at that time, but it was syntax checking and not semantics checking.
No, you need semantics.
Exactly. So here, it's semantics. So we provide
The knowledge semantic testing done the language that can program.
So how would you connect with the requirements, trace the requirements?
inside the tools, inside the specification, they say so there is a set of requests. Before a standard at the UMJ, you have a request for proposal. The request of proposal collect all the requirements that you need to satisfy. And so here we have a set of tests in the specification, and we have a trace for each test in the requirement. And then we can list.
Because this is embedded in software, it can be done. This is a very different story. But here, I mean, in what we were working on with the software, we should be able to do that.
If you look at the spec PSCS, precise semantic of composite structure, there is an appendix which is dedicated to the semantic of SysML for the block.
Well, that I want to hear. But we'll talk about that in the afternoon because, anyway, SysML is another story. Anyway.
Okay, I think I have to finish. So I remind you that you have all the information on the Papyrus website, and something I used to speak was an extension of UML for Mark for the real-time embedded system. And I can give you the book reference if you want. Look at that, and we can discuss about that later.
Thank you very much.
You're welcome.